question 3, we'll look at a second word problem that involves a linear system. So we are going to again create a linear system to model this situation. A school raised $140 by collecting 2,000 cans and glass bottles for recycling. The school received 5 cents for a can and 10 cents for a bottle. Now, if we look at this problem, we are going to start, as always, with a let statement to identify the unknown variables. And what's unknown in this situation is the number of glass bottles and the number of cans that are being recycled. So I'm going to let C equal the number of cans, and I'm going to let G equal the number of glass bottles. Now, when I go to write this system, these problems can be a bit confusing, so look for totals. Now, if we look at this, there's 2 sentences that include 2 numbers in each sentence, but specifically this first sentence includes 2 different totals. So the school raised a total of $140, and the school also collected a total of 2,000 cans. So these are our totals. This is what our equations are going to be equal to. So if we start this, since 2,000 cans, for our first equation, this will represent C plus G will equal 2,000. And the reason this is just C plus G is C represents the number of cans and G represents the number of glass bottles. So if we add these together, it should equal a total of 2,000. For the second equation, our total is in dollar amounts. So we would use this second sentence, which gives us an indication the school received 5 cents for a can and 10 cents for a bottle. Now we have to choose whether we're going to represent our money in cents or in dollars. I prefer to represent it in dollars, so I'm going to change these to dollar amounts. So it's 5 cents for a can, and we do have to attach some kind of money to each variable because the total is in dollars, and C and G aren't representing the costs of each, they are representing the number. So we have to attach money to them. So 0.05 times C plus 0.10 multiplied by G is equal to 140. Again, since this total was in dollars, I changed these to represent dollar amounts versus cent amounts. So I've finished A because I've written my let statement and I've written my 2 linear equations that are modeling this situation. For part B, again, I'm going to verify the solution. So if you look, it says the school collected 12,000 cans and 800 bottles. So use the system in part A to verify this. So to verify with my first equation, C plus G equals 2,000. Again, I'm going to remind you we are verifying in the end that once we substitute these numbers into the left side, that it is still going to equal the right side of the equation. So 1,200 cans plus 800 bottles. So 1,200 plus 800 is equal to 2,000. 2,000 is equal to 2,000. That is verified. And again, we'll verify it in the second equation as well. Again, I'll remind you that you do need to verify the solution in both equations. So if I substitute in C 1,200, and if I substitute in G, for G 800 in this equation, 0.05 times 1,200 is going to equal 60, and 0.10 times 800 is going to equal 80, and then 60 plus 80 is 140, so which is equal to the right side of the equation. Again, both of these are verified, so this solution is correct.